We want to write the equation of the circle in standard form and then give the center and radius of the circle. The equation we're given is the general form of a circle, and we should recognize this as a circle because the coefficient of the x squared term and the coefficient of the y squared term are equal. If they weren't, this would not be a circle. So our goal here is to write this equation in standard form or the form given here below. Once we have the equation in this form, the center will have coordinates hk and the radius will be equal to r. Looking at the left side of this equation, notice how we have the quantity x minus h squared, which means we want a perfect square trinomial in terms of x, and we also have the quantity y minus k squared, so we also want a perfect square trinomial in terms of y. So to write this in standard form, we'll have to complete the square for the x part and the y part of this equation. But to complete the square, we want the coefficient of the x squared term and the y squared term to be 1. So for our first step, we're going to divide both sides of the equation by 3, or divide each term by 3. We could have also factored out the 3, but for a circle, I think it's easier if we divide by the coefficient of these squared terms. Notice on the right side we divided by 3, but of course 0 divided by 3 is still 0. So we'll go ahead and simplify this and also set it up to complete the square. So the first term would be x squared plus, this would be 4/3 x. And now we're going to add a constant here to make this a perfect square trinomial. We'll find this constant in the next step. And then we have plus y squared. And then we'd have minus 2y. We'll add another constant here to make the y part a perfect square trinomial. And then notice we have minus 4/3. Let's go ahead and move that constant to the right side by adding 4/3 to both sides of the equation. So we'd have equals 4/3. And because we're adding two constants on the left, we'll have to add the same constants on the right to maintain equality. So now we're going to complete the square on x squared plus 4/3 x. To do this, we want to add a constant that would be half of the coefficient of x squared. To find half of 4/3, we'll have 1/2 times 4/3. Dividing by 2 is the same as multiplying by 1/2, and then we'll square this. Notice this product simplifies. There's 1, 2, and 2, and 2 2's and 4. So this would just be 2/3 squared. So we'll square the 2 and square the 3, that's 4/9. So we want to add 4/9 here, which will make this a perfect square trinomial, which we'll factor in the next step. Because we added 4/9 on the left side of the equation, we'll have to add 4/9 on the right side as well. And now for the y part, to find our constant, we'll take half of the coefficient of y, so -2 divided by 2, and then square it, which would be -1 squared, which is equal to 1. So if we add 1 here, this will be a perfect square trinomial in terms of y, so we'll also add 1 to the right. Now let's go ahead and factor this. We'll have two binomials here, which should be the same, and two binomials here from the y part, and then we'll find this sum on the right. Factors of x squared are x and x. Now we want the factors of 4/9 that have a sum of 4/3. That's not an easy question. The two equal factors that we need will come from the number we squared to get the 4/9, which is 2/3. This is positive 2/3 squared, so we'll have plus 2/3 and plus 2/3, which means 2/3 times 2/3 is equal to 4/9, and 2/3 plus 2/3 is equal to 4/3. This is why it's so important to show this work. This work does help us factor. And then for the y part, we would have y and y. We want the factors of positive 1 that add the -2, which would be -1 and -1. Again, notice how we squared -1 to get our special constant here. So we have y minus 1 and y minus 1. Notice in both cases, we have two equal factors. And then for the right side, we have 4/3 plus 4/9 plus 1. Let's go ahead and show this down here. 4/3 plus 4/9 plus 1, which I'll write as 1/1. Notice our common denominator would be 9. So let's go ahead and multiply this first fraction by 3 over 3. Second fraction already has a denominator of 9. And for the third fraction, we'll multiply by 9 over 9. So notice now we have 12 ninths plus 4 ninths plus 9 ninths. So we have a total of 12 plus 4 plus 9 ninths, or 25 ninths. Now we have all the information we need to write the equation in standard form. We have the quantity x plus 2/3 squared plus the quantity y minus 1 squared equals 25 ninths. And since we have the quantity x plus 2/3 squared, the x-coordinate of the center would be negative 2/3. And because we have y minus 1 squared, the y-coordinate would be positive 1. And when looking at the right side of the equation, r squared is equal to 25 ninths, which we can use to find r. If r squared equals 25 ninths, to find r, we would take the principal square root of both sides of the equation, since r has to be positive. So we have r equals the square root of 25 divided by the square root of 9, which would be 5/3. So the radius is equal to 5/3 units. So we found all the information the question asked us to, but let's finish by graphing this. We want to graph the circle that has a center at the point negative 2/3, 1, and has a radius of 5/3, or 1 2/3. So here's the graph of our circle. The center does have coordinates negative 2/3, 1. And if we sketch a segment from the center to a point on the circle, let's go ahead and sketch this segment here. The length of this segment, or the radius, is equal to 5/3, or 1 2/3 units. I hope you found this explanation helpful.